All right, so in this section, we're going to talk about polar coordinates. Okay, so polar coordinates is a pretty interesting concept. Is what we're going to do basically in this section is go from one coordinate to the xy plane to something called polar coordinates, where it talks about the radius and the angle itself. Okay, so we're just going straight forward to it. This is our basic xy plane, right? Here's the x's and y's, right, respectively, going up and down. So what we want to do is somehow using this transformation, where this now becomes this, where r is here and theta is now replaced with the y-axis. So r is replaced with the x and theta is replaced with the y. Now, there's one very key thing when it comes to this conversion is this theta right here is not always going to be perpendicular to the radius. It's going to tilt however we choose. So in other words, I can make it look like this itself. And that will still be the theta. The good thing is r is always going to be the horizontal scale. So it's going to be horizontal there, but theta will be curving depending on how we want it to be. Okay, and you'll see that in a couple of examples below. Okay, so using this concept now is we'll give it a point. Like for example here, right? We want to plot this point somehow in the polar coordinates. It's actually made a little easier than you may think. Okay, so before we go further, I almost forgot. Here we have x and y as a point, right? We go across x and up or down y respectively. Over here, the way this point's going to be is going to be r comma theta. Okay, so it's going to be if you see a point in rectangular coordinates, it's going to be r comma theta. So it's going to be the radius and the theta you're actually going to replacing. Okay, so when it comes over here, right? So this is going to be r and this is going to be theta itself. Okay. So how are we going to actually draw this out? It's going to be a sketch. It's not going to be a perfect full-on when it comes to it. Is you always want to do the theta first, and for that you kind of want to go back to your unit circle. All right. So plus for our case is pi over 3. Now pi over 3 is correct right here, right? So what we want to do is we kind of want to make an angle starting from here, and then making some angle going up there. So we want to make a kind of like a half triangle going like that. And that's going to be displaying our pi over 3. So it's kind of like this. So here is our portion, and here's, let's say, that. And that's going to be our pi over 3 angle. Okay. And all we want to do is, since our radius is 2, you're going to count as 2. So if this is assigned 0, you go 1, 2, and the point is going to be right here. So this is the point you're looking for, that one right there. So that is the point 2 comma pi over 3 with a radius of 2. And the 0 is always going to be at the center of your stick, which is a nice thing. Okay, and I'll show you what it means by a negative, how you do a negative in actually the next example. So what if I want the negative 2 and pi over 3? Okay, well, we're going to do the same thing, right? So here's our center. Here's pi over 3, right? Same exact concept. But we want negative, right? Positive was over here. So therefore, all we're going to do is make this go down even further. And now just count negative down here. So it's negative 1, negative 2. So this right here is the point, negative 2 and pi over 3. Okay. So same concept, right? When it comes to r being negative, it's just now instead of going up, we now go down respectively based off that. Okay. So let's try the next one, C. So radius is 1 and theta is 5 pi over 3. So let's go back and see, just make sure what 5 pi over 3 is. So 5 pi over 3 is right here. So we're going to have to make an angle going from here down to there, right? Because our angle is all the way around. Okay, so let's do that. So here's our terminal. And we're going to go down here because our angle is all the way around. It's 5 pi over 3 all the way around. And radius of 1. So 1. Now here's a trick question. This is a very, very tricky. This is technically still positive. This will become negative. Does that make sense? Because we're still going to the positive direction and not going the opposite. So let's say, for example, this is a negative 1. Negative 1 will be actually be over here. So I know it's pretty tricky when it comes to it. Just gets a little bit more practice when it comes to these kinds of things. The good thing is we'll just slowly get transition from here to go into different stuff. But this is just plotting a couple things to give you guys the basics of the the rectangular plane, or the polar plane itself. Okay, so don't worry too much. Right, and the last one is 3 comma 5 pi over 2. Well, again, where's 5 pi over 2? Oh boy, it's not our unit circle. Well, what was 5 pi over 2? So 5 pi over 2 is another way of saying, going back a couple sections, right? So 5 pi over 2 is the same thing as 2 pi plus pi over 2, correct? So we go the whole unit circle around, what's left over of pi over 2, so that's actually at 90 degrees, right here. So we're actually going to make a 90-degree angle this time, like that. And since we go 3 up, so here is pi over 2, 1, 2, 3, and there's our point there. Okay. So like I said, right, it's nothing too crazy. It's just a little practice when it comes to using angles and the radius itself. What we care about the most is these kind of stuff when it comes to this section, is converting from one to the other. That's the main concept when it comes to it. Okay. And unfortunately, one way is much easier than the other way, and you'll see that in a little bit. So when we want to go from the xy plane to the rectangular plane, we're always going to be using these equations here. So the x-coordinate is always going to equal r times cosine theta, and y is always going to be r times sine theta, which makes sense, right? Because x represents cosine, y represents sine. Okay, so that's how we're going to go from polar to rectangular. So polar to rectangular. So what we're going to do is all of these are going to be polar. We're going to go straight to the xy plane. Going backwards is a little tricky when it comes to this. So we're going to do the easy one first. Okay, so let's do this one. Okay, so we know, according to our portion, right, of r comma theta, so we know r, in this case, is going to be 3, and theta is going to be 5 pi over 4. Okay, now we want the x and y coordinates. So x is going to equal 3 times cosine of 5 pi over 4. And y is going to equal 3 times sine 5 pi over 4. And at this point, you can just plug it in and see where we are. So if you guys have your unit circle in front of you, 5 pi over 4 is over here, and we'll just plug in respectively what they is. So, 3 times negative radical 2 over 2, and the same process, right? So our x-coordinate is going to be minus 3 radical 2 over 2, and the same thing is going to be for our y component. So that's our point in the xy plane. So negative 3 radical 2 over 2, comma negative 3 radical 2 over 2. Just like that. Okay, so let's try another one. So this is r, this is theta. So x is going to equal negative 2 cosine of pi over 2. And y is going to equal negative 2 sine pi over 2. All right, so cosine of pi over 2 is 0. So 0 times anything is still 0. Sine of pi over 2 is 1. So 1 times negative 2 is negative 2. So that is our point in the xy plane. Right, so it kind of makes sense, right? It's a 90-degree angle because it's pi over 2. And we get the radius of negative 2. So that's pretty interesting, right, when it comes to it. Okay, let's keep going. So this is r theta, right? So this is going to be x is equal to negative 4 cosine of 11 pi over 6. And y is equal to negative 4 sine of 11 pi over 6. So again, just going back to a unit circle, here's 11 pi over 6, right? So our x component is going to be negative 4 times this, which should give you leftover of negative 2 radical 3. And the y component is going to be negative 4 times this, which should give you just positive 2. So those are our points in the xy plane here. And then the last one, again, r theta. So x is equal to 1 times cosine of 2 pi over 3, and y is equal to 1 sine of 2 pi over 3. Right, so cosine pi over 2 is over here. So that's just going to be negative 1/2 and radical 3 over 2 as our point in the xy plane. And there we go. That's it. So all this is just identifying what your r and x is, and just plugging them into an equation and slowly simplifying at that point. Now, like I said, this was the easy one, going one way. Going backwards is actually a little difficult because there's a little bit more steps involved. Okay, so now let's actually try going backwards. So let's go from the rectangular plane to polar coordinates. Okay, so let's suppose we have the point 2, -2 to help us out. Okay, and we're just going to graph this in the xy plane. See how that would go. Okay. All right, so 2, -2 is down here. Okay. Remember, in order to get a polar coordinate, we need an r and a theta. Well, the r is actually not that bad because if you notice, we can make a right triangle any way we want when it comes to that. So that's how we're going to find r. So this is going to be -2, 2. So r is going to equal r squared, right, is equal to 2 squared plus -2 squared. Right, so we use the same process we did in a couple sections ago to find r. So r is going to be the easiest one to deal with. Theta is going to be a little tricky when it comes to it. So we'll find this one. So r squared is equal to 4 plus 4. So radius is radical 8 or 2 radical 2, right, when it comes to it. So that's how we're going to find r. Theta is going to be a little different, okay? So I'm just going to straight out tell you what you're going to use instead of just, trying to manipulate it. Is we're always going to be using tangent theta is equal to y over x. And we're just going to solve backwards to find theta, okay? And then xy represents, coming back to our xy plane, right? So for instance, right, this is x and y, so tangent theta is going to be -2 over 2. So that's just going to give you -1. And now the question becomes, when is tangent equal to -1? So for that means you have to go back to the unit circle and see when we get -1, right? Now, the key thing when it comes to that trick question is, right, -1 or +1 is they both have to be the same number, right? Because number over number gives you 1. That's what you want. So it's going to be here, there, there, or there. Well, since we want -1, so one has to be the opposite sign, right, when it comes to it. So it's going to be either here or here. So there or there. Now, tangent, however, it doesn't go around to the whole unit circle. You guys remember, it goes from 0 to, pi over -pi/2 to pi, pi over 2. So therefore, it goes through here, right? That's the most important one. But the problem is, 7 pi over 4 doesn't mean you're going all the way around. So what's an equivalent of that? So an equivalent of that would be going from here to here, right? So that would be -pi over 4. So essentially, this is the same thing. So this beam is the theta must be -pi over 4 to deal with it. Because again, 7 pi over 4 is not in the domain of tangent, or the range of tangent. So you have to go the opposite direction. So remember we talked about that in the last couple sections. So there's your theta, and your r is radical 8 over radical 8. And that's what we're going to have to do going backwards. So that's, like I said, it's pretty lengthy going backwards, pretty tricky. But the good news is I do give you guys a summary in the back how it's going to be, okay?